we're recording the session, so anybody who misses it can catch up, or if you want to go back and retrace what we talked about as you're doing a quiz or your assignment or something like that, you're welcome to look back. And Kathy loads all of those up to Moodle within about 24 hours of the session after it's done what it needs to do. Okay, so this module we're going to delve into a bit more detail about that kinetic energy for different crash types at intersections and identify characteristics of intersections that align highly with safe system principles. And by doing that, sort of by default, we'll look at what doesn't align highly with safe system principles. And we'll have a look into mid-block characteristics that align highly with safe system principles. So mid-blocks being anywhere between intersections, really. So that's sort of the focus of this session, predominantly around vehicle-to-vehicle interactions. Next session's all about vulnerable road users, pedestrian, cyclists, and motorcyclists within the safe system. We do touch a bit on that within what we're trying to unpack here. Now, don't forget to keep your eye out and count your wallies, and they're appearing as per usual, and will be a question in the quiz. Also, keep your questions coming in the chat or the Q&A, and Kathy will feed those to me along the way. Like last time, there's a number of different activities and a few polls and things for you to get involved in along the way. There's certainly we're not too far into it. We've got an exercise where you need to do some analysing of an intersection and come up with some ideas. So we'll get to that shortly. I'll just remind you there, I did this at the start of last module, but I'll do it again because we've got the road safety audit, we've got that design review. The safe system assessment has elements that overlap that. So those of you that are road safety auditors or have been doing that for a long time, you know, that a lot of that process feeds nicely into a safe system assessment. It's just there's a bit more done and it's presented in a different way and usually used for slightly different purposes as well. So we'll get to all of that. The safety and design and the DDA stuff, and they all sort of have little bits of overlap. But let's jump into intersections and we'll have a discussion about intersections. So principles of intersection design to get high alignment with safe system principles. This slide has a lot of words on it. I don't like slides with a lot of words, but I'll jump through it quickly and then we'll actually sort of play these things out. The principle of having fewer vehicles is a really, I suppose, well-aligned safe system principle, and that can be, you know, altering different modes, putting people into different travel modes, and the like. And the reason that has decent alignment with safe system principles, and we're really impacting on the exposure to crashes. So I'm going to put a little E there for exposure to crashes. Because fewer vehicles, less people exposed to crashes. If you have fewer intersections, that's an exposure factor as well. So basically, if you can remove intersections by closing them off, and moving vehicles to safer intersections, we usually in a safe system assessment categorize that in the exposure as well. Fewer conflict points per intersection. So conflict points being just simply points where you can crash in different ways, and I'll show some conflict point diagrams. Conflict points within a safe system assessment actually influence the likelihood of crashes. So I suppose traditionally in road safety analysis, we have attributed that somewhat to exposure as a general term, but when we categorize things within a safe system assessment, we have made this sort of distinction that number of conflict points really is a likelihood factor of crashes at that intersection, because you're taking the whole intersection as a sort of envelope there. Then we get into impact speeds and impact angles. And remember, I'm predominantly talking about passenger vehicles here, but we get into pedestrian cyclists, motorcyclists later. But the speeds and the impact angles are where we're talking about the severity of the crash, okay? So the crash is now happening. This is about how bad it is going to be. And so the major contributing factors of how bad this is going to be that we, I suppose, have within the realm of our control are the speeds and the impact angles. Now, there are lots of other factors that come into play, like the frailty of the occupants, the restraint systems that are used, the vehicle features in terms of airbags and those sorts of things. Less in control for us within an infrastructure project. At a policy perspective level, we can control some of those things. We can factor some of this into our intersection design as well. And I'll talk to you about that. But the classic examples, if you identify the area as high proportion of older road users walking around or driving around or the like, well, you might consider that within your safe system assessment to potentially lower impact speeds due to vulnerability. But really, we've got that 90 degrees collision speed around that 50 kilometers per hour mark. Where you can get more angle on that crash, the speeds can go up a bit. The reason for that is that, back to year 10, year 11 physics and vectors. I mean, if you crash like that at an intersection, the energy is pushed out into the environment as your vehicle sort of crashes like that. If it's more of a right angle crash, the energy is more focused into the other vehicle. You still get obviously some there. So the angle is important. If the angle goes to a bit more head-on, I'm running out of space, a bit more head-on, the front of the vehicle starts to come into play in terms of those crumple zones, airbags, seat belts, and all the good safety features packed into the front of the vehicle. So this is where we say, somewhere around the somewhere around the 90 degree crash, we're talking around the 50 kilometers per hour or below to get us some pretty good safety outcomes. If you give it a bit more angle on it, you can probably go up to around the 60 kilometer per hour mark. This is passenger vehicle to passenger vehicle crashes I'm talking about. And really that head-on's around that 70 as a threshold limit. If we start to get vulnerable road users involved in any of this, we're talking 30 kilometers per hour or below as that collision speed we're certainly aiming at, and that has lower likelihood of death or serious injury. And then when you can't meet these requirements, you're looking to reduce risk in other ways as you practically can. But in this ideal sort of safe system world, if we've got intersections and we're trying to manage the energy, we either need to keep the speeds within these tolerable levels, or we need to either look to grade separate, close the intersection. That would be good, but we need to still access things, so that can be a big challenge sometimes. Or you need to start to look to accelerate vehicles up, because this is really a change in speed that we're worried about, a delta V, rather than the travel speeds as such. So if you can get a vehicle up to a certain speed and the change in speed is not so great, the initial crash can be very tolerable, and it can all be done at very high speeds. You've got to worry about, obviously, your secondary crashes in those situations. But if you are able to have an acceleration lane and the crash happens and this vehicle is going sort of 80 and this one's going 100, that initial crash with those angles is very, very tolerable. And yeah, but think about what happens inside that after that secondary crash. But here's one of sort of another table that's there, and I do want you to referring back to these when you get to the point in your safe system assessments where you're looking at the severity factor. I want you to look at this. I want you to look at that colorful graded chart that we put into module 1. That'll be a really great source of intel for you. A lot of this comes from a model called ChemX or XChemX, which is the kinetic energy management model. And that's really, I suppose, just a bit more in-depth analysis about energy during crashes at intersections. Now, utilization of XChemX and the like is far beyond what you would need to do in a safe system assessment, unless there was some specific requirements, but that would be very rare. Within a safe system assessment, you're just getting a general feel for whether this is sitting within what we think is generally tolerable for this type of crash, or this is way higher than we know is tolerable, and apportioning scores accordingly. We'll get to that. You'll practice it. Don't worry if you're a little confused so far. But you can sort of draw angles. You probably don't need to, you definitely don't need to be this precise, but you can sort of see that, oh, okay, so this is around a 90-degree crash as a vehicle comes out of here. Planning a new intersection here, vehicles coming out. The crash could be around a 90-degree for the first carriageway. The other carriageway, that's much less. So the second carriageway, probably a 60 km/h is about that threshold speed, about a 50 for the one that's close to 90. So you're getting that idea that we're correlating speed and angle to understand injury outcome or likelihood of injury outcome for the occupants of the vehicles. That secondary crash is quite important to remember. Certainly, we know that there is an initial energy transfer impact in that crash type. Then there's the vehicles going off and crashing potentially into other stuff. Now, these intersection crashes don't very often happen in this very right-angled square right in the middle of the vehicle type. There's there's a major raft of variety of things that happen. There's vehicles that clip other vehicles because they're trying to avoid and they leave the road that way. There are these direct impacts. There's all sorts of different mechanics of these crashes. But if you do look at the research around I suppose runoff road crashes or secondary crashes into roadside objects around intersections, probably fairly obvious. Maybe we don't need the research to tell us this, but this has been graphed and plotted out to the same axes. But you have if a vehicle's entering from that way and a vehicle's entering from that way, and there is some sort of impact between the vehicles at the intersection, we know that the majority of the crashes are in that field. Okay, that's understandable. You get some clip-offs and some different ways that they go. The other thing that's important within a safe system assessment is to understand that there is an increased likelihood of runoff road crashes around intersections. And there will be no vehicle-to-vehicle contact. However, one vehicle is avoiding another vehicle that's pulled out, that's started to make a bad move. They've lost control and they run off the road. So when you're analysing intersections within a safe system assessment, you're likely to put your score for runoff road crashes up a little bit, as in increase the risk of runoff road crashes around intersections. And that becomes a really interesting point. And a lot of you are probably, your mind's going to this already, that we put a lot of fixed hazards around intersections, don't we? I mean, in a lot of in urban environments, there's signal poles, which are rigid. Your sort of 2B style pole is a rigid pole. We often see power poles around intersections just for one reason or another. That's the way they're often configured to move the line around or the like. And there's often trees and things around the intersection. So it presents us with a challenge. Certainly, I am very interested in the idea of a slip-based signal pole, and I know that there was some initial work done to try to trial that in Victoria. There's a lot of challenges, and there'd be a lot of work to get it happening, but we do often just completely sort of ignore that issue. And we do see quite a bit of trauma for people at intersections striking the signal pedestals. But yeah, keep coming back to the numbers, the angles, the speeds, and the sort of outcomes we are expecting. Now, I could keep talking a lot about intersections, and I'll talk a bit more about after we do a little exercise, but I think it's time you did an exercise. And I'm going to show you an intersection, and I'm going to ask you to do some work to make the intersection better aligned with safe system principles. I'll show you the intersection, and then you can, and then I'll give you your task, and then I'll give the opportunity for you to get clarification, ask any further questions. Okay, here's our intersection. It's a divided highway, major arterial road. It's a B double route, so it takes large vehicles. It is a 70 km/h speed zone. This is a local road with a 50 km/h speed zone. This is like a shared use path. Obviously, it's a residential area. This is like a drainage culvert style thing. This is a bus stop, so there's buses on the route, and it's got a right turn lane in there. And right, you can go right out, left in, left out. This is a service road, two-way service road. You can see there's a keep clear. There's a set of traffic signals down the road here, maybe about a kilometre and a bit. So signals down there. There's signals also down the page, again quite a bit away, but there's traffic signals there. Traffic volume and the main carriageway, about 19,000 vehicles a day. 19,000, and about 10% commercial vehicles. Side roads running about close to 2,000. No, 1,500. Let's go. Yeah, 1,500 in our scenario. Vehicles a day, and sort of very low commercial vehicle, just mainly service vehicles. Although some buses do come in here because there's a school down the road here, about 400 metres down the road. There is a crash history here, which I'm not going to give you too much details in that, but the crashes have all been passenger vehicle to passenger vehicle crashes. There is a pedestrian crossing, what we would call a Danish offset crossing here, which is where you sort of have that Z, sometimes actually called a Z crossing, where you go in and you walk up a bit along the median and then you cross. That was actually what I would say a backwards. That's not good practice to have it staggered that way. You'd stagger it the other way because you're walking against the view of traffic when you cross. It'd be better to cross in there, go down that way, and then cross. But they got a culvert to work with, so that might be the part of the other challenge. Anyway, okay, your mission, your task is to do whatever you want to this intersection to make it better aligned with safe system principles. And I'm really not going to give you too many limitations. Well, I'm going to give you 3 pretty big ones, actually. The first limitation you have is that you have a budget of $2.2 million. Now, some of you might go, oh, I don't know how much things cost. So what I also am going to provide is a service of cost estimation, instantaneous cost estimation. So you want to do something, you can type it into the chat and I will immediately tell you what that will likely cost at this site. Now, obviously, there'll be a bit of me having a guess at it, but it'll be a ballpark crack at it. So don't worry if you're not somebody who actually, designs and procures and estimates these sorts of things. So that's one limitation. You've got $2.2 million. Sounds like a lot of money, but when you're building infrastructure, it's not actually a huge amount. You can do some significant changes here with that, though. Okay, you've got $2.2 million. Second one is that the community consultation has all been done, and there's been some political commitments here. Access in and out of this intersection in all directions must remain. So I know some of you are going, first principle there was actually it was the second principle, can we have less intersections? Can we close this whole thing off? No, the answer is no in this one, because we must maintain that access in all directions. So being able to turn in from this way, turn out. So that's number 2. Can't close the intersection as much as you wanted to, and I applaud you for that thinking. Well, actually, you'd want to analyze where you're going to push all the traffic to, would be what you'd want to do before you do that anyway. And the third one is that you are operating in the current political and organizational climate that you currently sort of work in, or if you're a consultant, the state road authority that would own or would manage this in your jurisdiction. And so if you're coming up with, I suppose, revolutionary ideas or things that are quite forward thinking, I want to hear a little bit of a plan about how you're going to get that through and actually built. Okay, so what you're going to do is have a think about this, and I know you're already all thinking about ideas and changes and the like, and then you're going to type in your idea, but you're also going to have to type in whether you are influencing exposure, likelihood, or severity, or a combination. So if you were to say, oh, I don't know, I'm going to pick some random thing. What's something that, okay, let's go with, we're going to put some road safety barrier over this culvert, okay? Or, protect road users from dropping down into the culvert. Then you would say, so I'm going to do that, and that is going to influence the severity of crashes. So in the chat, you would write road safety barrier at the culverts, and then just put a little bracket S, or write dash severity. So I really want not only for you to be coming up with ideas that will improve alignment with safe system principles here, but to be starting to get yourselves in a process of categorizing things into exposure, into likelihood, into severity. Now, I'm going to get you to do that in this exercise. You're going to do it in your assignment, and then you're going to do it in your safe system assessment. So it's a great start for us to practice that. Let's just have a quick look at the site from ground level. There you go. You can see the vehicles coming out there. You can see the bus stop over here. It's looking very, very good there. There's that sort of culvert drop-off bit there. 2 lanes in each direction there. Service roads and trees, bit of a median there. Okay. So what I'll do now is I'll pause for questions on clarification of your task. I'm going to give you a good sort of 7 minutes or so, 8 minutes to have a ponder of this, to write some ideas down, to put in your questions about costs. But I'm going to pause now and see what people are asking.
Ken, straight into it. This is very exciting. You're going to get a lot of responses here. Okay, cost, your famous Ken cost estimator. Can you tell us fully signalised intersection with red light cameras? What would that be?
Fully signalised intersection with red light cameras, $1.5 million. Actually, 1.7 million. The intersection's set up quite nicely for traffic signals. Probably somebody back in the day when it was originally done maybe pondered that and it was set up. So 1.7 million.
Right. Can you tell us how much for a pedestrian bridge grade separation?
A pedestrian bridge grade separation, meeting all the DDA requirements, $2.8 million.
Okay. Over budget. Can you tell us cost for a signalised intersection with raised platforms?
Okay, raised platforms. So a bit more cost there. That's $2 million.
Excellent. What about a separated cycleway?
It would depend. That's a very good question. It would depend where you put it and the like. But I'm going to go with utilising part of the service road and the like. So stretching it up and down. I'm going to go with 500,000.
Excellent. This is a very quick cost estimator from you. Well done. Just a reminder, because there's so many responses coming through, to pop in an E, an L or an S. So is your suggestion influencing exposure, likelihood or severity? If you pop that in with your response.
That's a really good point, Kathy, because I'm seeing a lot of responses in here with some ideas on treatments and not telling me whether that influences exposure, likelihood, or severity, or a combination of those. So if you've written something in and you didn't, go back, write it in again and put a dash exposure, dash likelihood, dash severity. I see a couple of, is there a question on the cost of a roundabout I see, or people talking about a full-size roundabout to cater for the, in alignment with the Austroads Guide to Road Design Part 4A, somebody can correct me if I got that wrong, roundabout design is going to cost you $5.2 million at this location, because you've got services, which I didn't even tell you about. You've got this massive culvert to move. The size of it's going to be big. You're going to have to require land, and there's a whole lot of challenges associated with that. So that is a full-size roundabout.
Oh, sorry. Can you tell us how far away is the signalised intersection to the north?
I'm going to go with 800 metres to 1 kilometre.
Okay. Would you be able to put in signals and extend the culvert to the right of the page?
Extend the culvert out this way. Yes, you can just do that. Yep, you've got to get some good contractor prices, but you've just got that within budget. 2.2, right on the dot.
Okay.
Don't ask for any variations.
I think I've got all the questions so far. There was another question about grade separation, but I'm not sure if that was for I assume that was pedestrian.
Well, if we went grade separation for all vehicles, so a full sort of flyover, a colloquial term for it, that is going to be $31 million.
Oh, okay, right. So it's just a tad. Oh, what about a pedestrian underpass?
Okay, so it depends. So creating a fresh new pedestrian underpass, or even utilizing some of the existing infrastructure and digging this down, and maybe making some light requirements. So cutting out there. That's going to be 1.1 million. It's a bit annoying for a few things there.
Okay, great. Now we do, this is a bit of a first, but we do have someone in the group who knows this, Ken, because they worked on this.
I actually knew there would be somebody in here. I saw some names, so that's fine.
That's good, isn't it?
It is.
All right, I think everyone's well and truly into this exercise here. We've got a ton of responses.
Yeah, I'm just sort of looking through. This is excellent. Really great responses coming in. And I'm liking the fact that almost everybody is putting, yep, now exposure, likelihood, and severity. And it is fine if you picked which the intersection was. That's not an issue at all, because we're doing a combination of things with this. Yeah, certainly looking at what could be done in these sorts of environments, but really a lot of focus on that exposure, likelihood, and severity categorization, getting that clear in your head. And so we'll have a chat about it. But let's have a look at what some people were saying. So, okay, let me just read through a few of them. Some of them everybody went to all the panelists and attendees. Some people were just doing it to the panelists, which is fine. So I'll just read through a few of them. So we've got a lot of people trying to look at the operational speed through the intersection via speed limits or via other means, and identifying that will reduce the predominantly the severity of the crash, potentially a bit of the likelihood as well. So that's good. We've got an interest in signalizing the intersection, because people, have identified a number of characteristics here that probably lend itself to signalization. And we'll go through that in a bit more detail. And rightly, people there are identifying that influences the likelihood of crashes. Not going to do anything for the severity of crashes with just the signals. Then we had a few people who are wisely, I would say, thinking about, well, can we also add something to influence the severity of the crash at that intersection as well? And that's maybe something to influence the operating speed, be that a speed limit, speed camera, a raised safety platform, or the like. And so then we've got people wanting to lower the speed limit again, and we're dropping it down all the way to 50. Some people want to drop the speed limit to 50. I dare say that one's, pushing us quite a bit. When you saw the photos of the road here, not to say it's not possible. I would like to hear a little bit about how we can talk to the community about a speed limit reduction of that magnitude on a road like this. So some ideas on that would be good as well. So we've got high friction surfacing on the approach to the intersection. So when people slam on the brakes, they are going to get better traction and slow down and stop quicker. We tend to categorize that in a safe system assessment as a likelihood factor. It will certainly sometimes impact the severity of crashes, but it gets categorized into the likelihood simply because if there is not that sort of reaction to the vehicle exiting or that mistake, the speeds are still just as high as they were going to be. So you're still relying on that human noticing of that specific issue and I suppose taking action accordingly. We've got roundabout. We've got the desire for a roundabout in terms of the influencing the severity of crashes. We categorize roundabouts as a severity reducer for intersection crashes with passenger vehicles. We tend to not give it a reduction in the likelihood of crashes because we do see often a lot more rear ends and side swipe crashes, especially because this would be a 2-lane roundabout. We'd be expecting some side swipe crashes. The severity of them would be much lower though, so correct on that. We've got some ideas on undergrounding the electrical services and relocating the bus bay and barriers to protect the culvert. And on that, so relocating the bus bay would be a likelihood factor, absolutely. And the barriers to protect road users from hitting or dropping into the culvert or the trees or the like, that is the severity. Because remember, when you hit that barrier or when somebody hits that barrier, that's a crash, okay? We just know the severity of that is really low compared to the severity of dropping into the culvert or hitting a tree. And the undergrounding of services, that's one where you could probably argue either likelihood or severity. So you've got to then think about, well, okay, there's no power pole there to hit, that's good, but what else is there to hit? Because that's the runoff road crash we're interested in. Have we made it less likely that there's a runoff road crash because you leave the road and you might recover? Or have we changed the severity because now you hit a house or something rather than a point source hazard like a tree? Okay, we've got some people in there talking about maybe smaller roundabouts. Why do we need to spend that $5.2 million or whatever I said for a roundabout? Why does it need to be so big? Can it be smaller? Can it be a compact roundabout? I'll come back to that. So lots of people talking about traffic signals. And there's a little bit of people wanting to ask whether traffic signals influence the exposure to crashes. They don't. We don't tend to do that unless for some reason it has a major change in the way people travel. So we get more people using the intersection or less people because of the signals. But the idea that it tells people when to go and when not to go, that doesn't influence the exposure to crashes. That influences just the likelihood that they're going to crash. Exposure is really the number of vehicles going through this intersection. This is fantastic, Kathy. The huge amount of ideas in here are great, and there's even a bit of conversation going on within the group, which I love to see. Okay, I'm going to come back to some of the comments, but I want to show a few slides to take you through this. But I really thank you on all of that. The one thing that I will say before I launch into some other information is that I never actually said that it could only be infrastructure works or speed limits that you can do. I just said do what you want to rectify it. Now, I noticed that now maybe it's because most of us are working in the infrastructure space and that's where we're very focused and that's what we're thinking about. And maybe I subtly led you down that track for one reason or another. But you could have talked here about other elements of the safe system. So you could have talked about education with the school on how to use the intersection. You could have talked about ways to maybe encourage better vehicle use. Anything like that absolutely would be stuff that we do also want to think about within these projects. We don't want to just confine it to our infrastructure and our speed limits, so the pouring of concrete and the like, and speed limits. We want to think, broadly, can other things be done? We are part of a holistic system. Okay, so remember that we did say, sorry, there was just a few other ones coming in for possible ideas. Remember, we did say that we have to provide full access to that intersection. That was one of the requirements. Okay, a lot of you went for signals, and it's probably lends itself to show the experience in this group. People looking at signals because they understand some of the challenges of an intersection like that with the unbalanced flow. So you've got a low number of vehicles on the side road, big number of vehicles on the main road. It lends itself to controlling with signals because roundabouts often have some unbalanced flow challenges where one leg will dominate if you have that unbalanced flow. That being said, I think we can come up with some other ideas on that. But I'd like to use this little diagram down here throughout the slides. And it's really a reminder that we need to keep categorizing things in our mind. And signals, we talk about likelihood. I did notice that a couple of people even specified that fully controlled right turn. Okay, that red arrow. So that's a great likelihood factor. Really works well, and especially the fact that that was right turning over 2 lanes of traffic, and we get dynamic visual obstruction issues, that masking issue that often arises. And so being able to control that is a really effective likelihood factor. The challenge we have, though, is we're going to see if we were to just do a stock standard signalization of that intersection, we leave the speeds through the intersection quite high. And I just grabbed a random snip of heat mapping of fatal or serious injuries in some of these areas where you get about those travel speeds, around the sort of 60, 70, 80 kilometre per hour on the major arterials. So I just snipped a random bit of the heat map here. Okay, we can see hotspots of death and serious injury, can't we? And I don't think it's going to be any surprise to a lot of you here. They are all signalized intersections. They're fairly large signalized intersections. But hang on a second, isn't there something a little bit odd here? We've got these signalized intersections. We're telling everybody you can go, there you have to stop. But these are the hotspots of death or serious injury in these outer metropolitan environments. Why is that? Well, it's because humans make mistakes. And they do it at full speed, as somebody's just written in there. They do it at full speed. And sometimes they do it even a little bit higher than the speed limits or even what they're traveling. They put the foot down. And the issue we've got is this absolute belief of priority for one road user or the other. So a road user is driving along and they've got a green light and they're almost switched off to that. They don't change their travel speed. They don't tend to get a lot more alertness. We'd like them to have a look around as they're going through the intersection, check everything's good, but we know the majority of them are switched off, driving along, they've got the red light. And so if somebody enters that, we have high speed, we have a bad angle of crash, and it's playing out with a lot of death or serious injury. So Professor Jeremy Woolley out of CASA, the Centre for Automotive Safety Research, said at one point during the National Inquiry into the Road Safety Strategy, he said, traffic signals are the biggest failure of traffic engineers, which It's a fairly provocative statement. So this is the reason he was saying that is because there is a lot of belief that signalisation is the ultimate intersection treatment, I suppose, before it gets grade separated somewhere way down the track. But once you've got it to a signalised intersection, fully controlled turns, if you're worried about safety, there's nothing more you can do. Well, we need to change that. We really need to change that. And this group is obviously quite attuned to what's going on in industry and quite forward thinking with their comments around something like raised platforms or something to slow vehicles through these intersections. Because let me tell you now, just signalising an intersection ain't enough. It's enough if all the speeds we know are within these tolerable levels already, or they're going to go through that. But if not, we need to do something else. This is one of the reasons why roundabouts are so well aligned with safe system principles. I mean, they are, sorry, I'm just trying to grab another document as I do this. They reduce travel speed through the intersection. Big win immediately, right? They make people aware that they might not have priority through this at any time. Another big win. And we've got some reductions in conflict points. We get some other crash types that appear, but that's okay. But we do have that unbalanced flow issue. And there are ways you can deal with unbalanced flow with metering your roundabouts. Metering is basically, putting signals at one leg or two legs or however many legs you want to try to manage your flow, meter your flow of traffic to try to make that happen. I like metering roundabouts and making them pedestrian cycling crossing points. So you get a nice crossing, but you also get to manage your traffic flow. But this is obviously not the same site. We would have bought a lot of houses, or they would have bought a lot of houses. But you can see there, even just the land requirements, it's big. And that's because often vehicles need to, large vehicles need this big area to sweep around, to get around that. But yeah, there are smaller roundabouts, and it was nice to see some people talking about compact roundabouts. Now, this is what I would call a mini roundabout, not a compact roundabout, but it is certainly a possibility in a lot of these sorts of environments. Now, some of you are probably worried about the fact that we don't have much angle change here. We don't have much deflection on the approach. Is it going to be, our speed's going to be high? Yes, we've got some challenges from that perspective. But where we get really big wins immediately off this, just this, lick of paint, okay, there's a bit of a splitter island as well. Where we get immediate gains on this is that any vehicle approaching this does not believe they have that ultimate priority. So they're going to wake up, they're going to look around, they're going to hopefully slow down and make that decision that they are safe to travel through. And that's actually a pretty big win. These ones are nice because you go, well, a larger vehicle can just drive straight over it. And so that's covered off the ability to get vehicles around. Very urban environment, very different environment to what we were dealing with, but the concept's quite nice to think about. If you're worried about that straight through approach, speed, and the like on some of these smaller roundabouts, you can think about these, raised platforms on the approach, slow vehicles down, and you're addressing that as well. So there is possibility there. And with roundabouts, we're talking about the severity of crashes. There's a conflict point diagram, basically a really simple one. This is sort of road safety engineering 101, isn't it? Just simply less ways to crash. Each dot represents a possible crash, and you see a roundabout, one-lane roundabout, and this is not including cyclists, pedestrians, cyclists and pedestrians, which we'll talk about a fair bit next module. But just the less ways to crash. But you actually do introduce quite a bit of rear end, as I mentioned. You've got the angle of crash is better at a roundabout. And you've got this one, which I've mentioned now a couple of times. But basically, if you put a large, lumpy infrastructure in the middle of the road, people wake up from wherever they are. They're driving along in a half asleep state. They're thinking about the fight they've had with their partner, whatever it is. They're completely zoned out from the actual driving environment. But there's a big, thing in the middle of the road, a roundabout, and they come back to it. They come back, they look around, they slow down. These are just all-round wins in road safety. And people drive in all sorts of states. We're going to try and discourage all of that, but let's be real about this. There is just going to be a continual amount of people driving who are not alert, who are zoned out. And I mean, a lot of I won't get you to write in whether you've driven straight through a red light and gone, did I just drive through a red light? Or whether you've driven for 10 minutes and you've gone, I don't remember anything of the last 10 minutes of driving. And it's because, you tuned out, you're in another state. What we were trying to do within the road environment is at these conflict points, at these points of high energy, high potential, crash, bring you back, wake you up. Roundabouts have some other challenges, I suppose. Single lane, double lane, turbo roundabouts. I won't talk about this in detail, but basically you can generally use speed through a roundabout as a proxy on the safety outcomes you're expected to get. The bigger, so this is in a radius, the bigger the roundabout tends to be the better. Two-lane roundabouts have a lot of challenges because people straight line it through a two-lane roundabout. If you make it a turbo roundabout, which is a type of two-lane roundabout, you can bring it back to basically operating as good as a one-lane roundabout for a two-lane roundabout. So this is a turbo roundabout. I mean, this is almost just out of interest, but it does have some better alignment with safe system principles when you safe system assess it, actually, compared to a different one. So basically what it is raised separator on the approach, raised separator through the roundabout. And so if you want to turn right, you've got to get yourself into that right lane and you've got to turn around. You go out there, you go straight through as well. But if you want, you can't take that straight line through. There's another example of a turbo. Gee, look at this. We've got conflict, this will be a near miss or a crash. But look at the angle that's going to happen if it does happen. Wonderful. That's good to see. Obviously, we wouldn't like them doing that, but we're okay with those sort of crash angles. That's going to be a very minor crash. We know the speeds will be low. We know the angle's great. That's a great example of what we're looking at. And the turbo roundabouts can be pretty massive. This is out of the Netherlands, and the reason I popped this in is not to say that you're going to build that at the intersection, and that would really blow your budget. The thing is that I was talking to a Dutch engineer that we brought over to talk about cyclists at roundabouts and the like. And I just showed the Dutch engineer this one, and I've never seen it live, but I was like, this just is amazing. I mean, the huge land take and in Australia, we would just have that as a large signalised intersection, or if it eventually got there, it'd be a grade separated interchange. But I said, everything I'm seeing there from what it would probably be a large signalised intersection with 3 lanes on each approach and big signalised intersection. And the response from the Dutch engineer was, "And what about all the death and serious injury?" And I was like, yeah, I know, I agree with you. He could not fathom that we would possibly put our community through that risk. But we do it all the time. And I'm constantly seeing us creating new large signalised intersections where we know the through speeds are going to be 60, 70, 80 kilometres per hour, and we somehow expect we're going to get a different result. But it's got mast arms and it's got LEDs. We really have to change the way we look at these intersections. Now, Kathy, I'm going to pause there and see if there's been any comments so far. I'm sort of just starting in my journey on my rant about signalised intersections in their traditional high-speed form.
It gets me every time, and it's not a rant, and it's the pure definition of insanity, isn't it? We keep doing the same thing and expecting a different result. So some comments here about, say, signalised intersection helping with network performance and volumes. Can you expand on that a bit more?
Yeah, no, that's absolutely right. So we know that roundabouts don't get as much volume through them and the like, and often they get quite saturated, and the performance isn't as good as we would like it to be from that perspective. So we know signalised intersections perform quite well from that perspective. I think we just need to find the way that we can do that without them causing death and serious injury to our community.
Okay. Now it looks like for this particular roundabout that you've got on the screen here, does this sort of setup create more points of severe crashes, T-bones?
Not at all. There's conflict points there. Don't get me wrong. There's quite a few conflict points. But the thing is that any approaching driver sees this. They're not driving through completely blindly, half asleep. They're driving through and they slow down and the impact angles are better. And they're going through here at speeds that are within our tolerable levels for these crash types, 50 kilometers per hour or below. So we know if crashes that happen, they're sort of lowish speed. So they operate really well.
And can you tell us, or actually Michael's responded with, people were asking about, are there any turbo roundabouts in Victoria or Australia? And he's responded with, there's turbos in Ballarat and Horsham. You familiar with those?
The Horsham one, yes. Ballarat, I'm not sure it's quite I think it's the one outside the Vic Roads office in Windaree there that Michael might be talking about. I mean, it's got turbo elements to it. I don't know. Well, we're getting into semantics here, so But yeah, the Horsham one is definitely there.
The screen has changed off the presentation. I just want to raise one more comment that's come through, comment and a question. How does the fact that roundabouts are complex go with traffic authorities? We're getting pushback from the authorities because these fancy complex intersections are new and different and people wouldn't know how to use it.
So
roundabout intersections? Roundabout intersections, I'm not sure which one.
Well, certainly roundabouts aren't new, and but I assume we're meaning things like turbos and cut throughs and the like. That's you'd be surprised at how good the travelling public is at navigating this stuff. We often look at it on the plan view, and we're very scared and it looks confusing. And when you're down at road level, it's actually quite good. There is a little bit of an idea that slower confusion is a decent thing for crash severity because they're slowing down. But certainly, I want to keep moving on, Kathy, because I'll sort of deal with some of this in some later slides. But I did want to just show something that I thought of as we were talking there, and I dug it out as we were talking. I apologize that I was looking at my other screen trying to find this. This is, are you seeing a memo there?
Yep. Oh, good.
Yeah, so this is back from my time in Vic Roads, and there was a congestion management program which was remove roundabouts, replace with traffic signals. As somebody mentioned, we know it's going to perform better from a traffic perspective. So ripping out roundabouts and replacing them with traffic signals, and usually in outer metro areas, high speed. And they were coming across my desk for safety review. And what they were all, what they were expecting with the safety review is, have we got good sight lines to the signals? Are we using, mast arms where required? Is the line marking correct? And all of that stuff. But I started creating this memo and sending it back. And so this was the memo that they'd get. They'd submit their new traffic signals, so RIP roundabout out, and so from the road safety department. So this was the memo. Road safety. The road safety department has analysed this project as increasing crashes as follows. Project life, and 20 years for a lot of them, or sort of 15 years, but anyway. Number of deaths attributed to this project, 2.3. Little pictures of people to remind them we're talking about people here. Number of serious injuries attributed, 12.6. Statement of acceptance, the above road trauma is accepted by, and then sent that on top of the design back to say, yeah, okay. You're making a decision here to get a little bit more efficiency out of your network, and you got to accept you're going to kill some of the community to do that and seriously injure a lot of them. Sometimes we have to boil these things down to this very simple statement. Did I ever get one of those signed back? No. Did I get lots of reprimands from my executive director and the like about things like, well, you don't understand the responsibility of a road authority is far beyond, this, we have to balance and, all of that sort of stuff. Well, no, that's crap in my mind. If we know we are actively going to kill and seriously injure our community by a decision like that, somebody needs to stand up and sign off on that. And we need to be in there sort of challenging this. And the unfortunate thing is around Australia and New Zealand, I'm seeing this just continue to happen. I was looking at a design yesterday out of New South Wales, ripping out a roundabout, replacing with traffic signals. Yeah, it's, nice investment. They'll get better traffic flow through there, no worries. But, back of an envelope, I can calculate how many of the community they're going to kill and seriously injure by making that choice to do it. So, it is more complex when you get like pedestrians and cyclists in there and other things like that. But let's not pretend some miracle will happen that everybody will stop at a red light. So how do we deal with that is the question. And I'm really, I was really quite excited to see this group and the answers that are coming in, meaning that some of the things that we can do on that. Now, I'm not saying that a turbo roundabout is going to be the answer, but why I put that slide up in particular was to show how some other jurisdictions around the world are completely just cannot understand what we're doing with these high-speed signalised intersections and will spend a ridiculous amount of money to avoid killing and seriously injuring their community at these large signalised intersections. Now, here's an example of one of those ones where somebody says it's, this stuff's too complex, and the community will push back. It's way too complex. Well, I think it's complex looking at it from up here, but I think if you're on the ground, you wouldn't find it as hard. These are the ideas of cut-through roundabouts. This is a mock-up. This hasn't actually been built. But this is saying, well, what can we do with these large signalised intersections to give us some of those safe system characteristics, some of those things that reduce speed, improve angle, and wake people up coming through the intersection. And the idea here being that, a vehicle coming along here is going to have to, go around this. They're going to wake up, they're going to look around, and it's all better. This is actually the reason for the cut through is trying to increase the efficiency and the throughput of vehicles. So you're not going to get full alignment as we want, but it's pretty good. The ideas are good. And in lumber, you mentioned raised safety platforms, and it's good. And Austroads has just had a release of a report on raised safety platforms, and there was a webinar, and I encourage you to jump onto the Austroads website and watch that webinar. Clearly says raised safety platforms are very good, and they really need to start getting rolled out on high-speed arterial roads to do exactly what we're talking about. And that was really what was chosen by the region, and certainly at least one, if not more, if you in this group who were involved in that. So I think Michael was involved in that one. That was the idea, the concept, reduce the vehicle speeds down on the approach to the conflict point. Now, why just here? Why not the whole intersection? Well, the answer to that is that these are our bullet vehicles, aren't they? They're the ones that are going to do the damage. The ones coming out from the side roads or going in, they're the target vehicle. They don't have the speed to do the damage. So you're just trying to slow the vehicles on the approach to a speed that's generally about within our safe system tolerable energy speeds, and that happens to be 50 kilometers per hour. The signals are going to do a really good job on the likelihood. The raised platforms to slow vehicles on the approach, the severity. Now we're talking safe system outcomes. Slow vehicles down on the approach, reduce the likelihood, reduce the severity, and we got into these categories. Now, pedestrians and cyclists haven't been catered for that, in the same degree. The signals will definitely reduce the likelihood. The severity will be down a bit, but it's still probably above our tolerable limit. So we might need to continue to work on that. But there you go, that one was built. So that is Surf Coast Kidman down in Belmont. And I know some of you know it very well. It was the first raised intersection of a large arterial like this definitely in Australia. And you can see there the advisory speeds are 50. And this is a little sort of tip I have, and I think, so if you can utilize advisory speeds over regulatory speeds and combine them with infrastructure like vertical deflection, like a raised platform like this, it is far more palatable to the public. They just tend to accept that. Like, I used to manage big part of the Gippsland Road network, and we were looking at two intersections along a road that we were particularly concerned about. They were quite far apart. They were probably 5Ks apart or whatever they were. And we all got in the room. We were really concerned. There was a crash history and there was high risk. And we said, okay, we're going to go for roundabouts. Roundabouts are the right thing at these two intersections. So we wanted roundabouts there, and it's 100. It was 100 kilometers per hour. Now, off we went and said, okay, we'll start the planning on roundabouts. And then, a few of us were uncomfortable. We got everybody back in the room. We said, how long actually until we get roundabouts at these intersections, do you think? And, the planners are going, we need to do this initial investigations and this, and then, all the planning work we need to do. There'll be land acquisition, there'll be services. We need to actually, get a bid together. We need to try and get funding for these. And they're like, 3 to 5 years. 3 would be very, amazing, but 5 years maybe. We're like, are we comfortable leaving this? We know this is high risk, and we just leave it. We said, no, we're not comfortable with that. And so we said, okay, we'll do speed limit reductions in the interim around these intersections. 400 meters before, 400 meters after. We'll make it 80. At least something to, alert people, slow people down a bit. Well, the community went berserk. They're like, this is revenue raising. There's, what are you doing? There's short speed zones, all of that, usual stuff that we hear. And so we had our town hall meetings and the like. We said, well, okay, these are identified as high risk. We need to do something. Our aim is to, we're going to get roundabouts in the future. For now, until we get those, we have to put these regulatory speed limits. And they're like, yeah, roundabouts, that's the go. We need the, get the infrastructure in there. Stop, spend the money. And, then they started lobbying the local member, and they're like, you need to make this happen quicker. Get rid of those 80s and get those roundabouts in there. And, we're sitting there going, this is insane. In Victoria, I should say, for those who aren't from Victoria, we don't put regulatory speed limits around roundabouts. We just let the geometry of the roundabout, slow people down, lots of advisory speeds. But I'm like, these people are insane, because when the roundabouts go in, they're going to have to slow down to 50 going through the roundabout by the geometry and the nature of it. But the point was that they were choosing to slow down, and the infrastructure was doing that. It wasn't us putting a red circle around a number and telling them that they have to do that, and in their mind, being out there and taking their money as a result of it. So if you can use these advisory speeds, a bit of infrastructure to slow people down, far better than that regulatory speed limit. Don't get me wrong, regulatory speed limit reductions work and they're great, and we really need to push that a lot. But let's pop that out there. And then this intersection, and there's quite a bit of analysis, and go to that Austroads report and have a look at it. It's wonderful to see this sort of stuff. But this to me is a beauty. Vehicle braking on the approach to a green light. This is exactly what we want to see. So, they're approaching the conflict point and they're reducing their speed down to a safe system tolerable speed. This also has some major benefit on reduction of the dilemma zone. So the dilemma zone, for those who aren't aware of the term, the dilemma zone is basically, as you're driving along, when the light goes orange and you are in a dilemma, do I put the foot down and go, or do I brake? And its official term is the dilemma zone, and it's a zone in time and space where you're in that dilemma. And what this does is it narrows the dilemma zone significantly, because the majority of people in what used to be a dilemma zone stop because they know they have this platform to go. So we get that, all these compounding benefits of this sort of treatment. And that's sort of the dilemma zone there.
Ken, questions coming through. If you can pause for a sec. What happens if you hit this at 80 kilometres an hour or 100 kilometres an hour?
So it's not like an urban local area traffic management speed hump. It's a shallow grade, and in that report, the Austroads report, or the VicRoads Road Design Note 703, you've got the grades and the speeds that are expect out of it. If you'd hit that at high speeds, you would likely get quite a jolt in the vehicle, but that's about all. People were concerned about all sorts of things, and probably others in the group can remember back to, people were like, oh, it's going to be chaos. There's going to be like Dukes of Hazzard cars flying over the road. They'll be running off the road left, right, and center. There'll be so many run-off road crashes. There'll be absolute rear-end carnage because people will be putting on the brakes. None of this is playing out. These are all things because it's different. It's new. People were, are super scared of any sort of change. And massive credit to the VicRoads Southwest region and their supporting consultants and the like for having the courage to plonk this out there on the road network, despite the huge amount of people who were pushing back against it. It's paved the way for heaps of them. And this one makes me happy. I mean, well, actually, the profile of the ramps don't make me happy, but the concept makes me happy. It's Dalton Childs Road, and we did a safe system assessment on it as well. But the idea, there was a roundabout ripped out, replaced with a set of traffic signals. But they made the commitment to keep travel speeds down within safe system tolerable levels using raised safety platforms. So now it's run of the mill. You rip a roundabout out and you're replacing it with traffic signals. You've got to get those speeds down. And we see a fair bit of that. So that's good stuff. And as I mentioned, there's the road design note and there's the Austroads document as well. Keep asking the questions, Kathy.
Thank you, Ken. I've popped that Austroads Raised Safety Platforms webinar in Module 2, link to the recording. I watched it on the weekend, so that's how exciting it gets at my place. Tell us about on the M4 in Sydney, they've recently introduced traffic lights to some of the merging traffic. This is not common for Sydney motorways. Is this considered a safe system approach or more about controlling traffic?
I would assume that means ramp metering.
So, yeah.
So ramp metering reduces the likelihood of crashes, and it's pretty well documented on that. So in that sense, when we do a safe system assessment on it, we get a increased alignment with safe system principles due to due to that. You've got to do a little bit of site-by-site investigation of how the queuing goes, whether it queues into other areas and the like. But in general, yes, we see safety benefits out of it and better alignment with safe system principles.
Complaints from residents about noise with array safety platforms?
Yeah, again, these are the things that were genuine, like super concerns, and it just haven't played out. The ramp grade helps in that situation. There are some, like the site you were dealing with, it's a residential area. There are houses all around it, but no noise complaints whatsoever. And some other ones that I was going to show you, which was, this is the compact roundabout site. And I'll talk to you a little bit about noise on this one. But yeah, there is noise possibilities. But again, I think they're far, far worse in our perception or our predictions than they actually play out to be. Yeah.
Do the platforms slow down emergency vehicle response times?
There will be a slight reduction in that potentially, because yes, they would slow down as with the buses and the freight, and all of these things you'd be concerned about, but performing really well, and
perhaps less emergency vehicles attending that.
Exactly.
All right.
I mean, we get so the roundabouts are classic. You put a roundabout in there, it would reduce the time for the emergency vehicles to get by, very similar, if not more. Nobody would be, making that connection. It's just that,
It's different.
It's new.
It is new. Gemma's also said that there's one recently installed in Hamilton in New Zealand and understands it's working pretty well. But yeah, Ken's already directed you to that Austroads webinar. It's an hour, and the link's in module 2. Just another technical question. Do they need piano key lines on the departure of the platform? Probably
not. That's a good question. The road design note does have them. I'm just wondering, you actually want to go as shallow as possible on the departure, especially if you're raising the whole intersection. Yeah, good question. Good question. I'll ponder that for a little bit. Certainly, you do use them in if they're the raised safety platforms, raising the whole intersection. Do you need it? Probably not. Yeah, Gemma, the one Gemma mentioned. Yeah, so Gordonton. Just outside Hamilton there. I had a look at it with Simon from Hamilton City Council before it was installed, and I'm yet to see it live. So Gemma, send me some photos. I mean, I've seen photos of it, but send me more photos. I want to see more photos.
Okay, 2 more questions, or maybe 3. Are there any race safety platforms installed on 80 kilometres or above in Victoria or Australia, or any that you know of?
Yeah, let's have a look at this compact roundabout, and I'll talk that through. Yeah, it's getting a little problematic above that, but potentially problematic. I don't think it would be, but anyway, that's. Was there another question? Because I will address that in a second.
Encouraging public transport and active transport in congested areas, given significance in safe system approach, wouldn't this reduce the number of cars on the road and thereby reduce exposure?
That's it's too. There's a long bow there to draw, and that would need some much smarter people than me to do big studies to work that out. But yeah, I don't know. I sort of just look at it site by site. But yeah, it's a fair question to ask. But what it does, it creates a much more friendly environment for vulnerable road users anyway. Slower speeds through, easier to cross. Lots of good aspects, and the signalisation helps a lot because it's clear when you cross, and so yeah, there's just wins all round for vulnerable road users as well as other road users. You may, obviously in highly pedestrianised cycling areas, or where you're trying to encourage that, you'd go even slower. So you'd make your grades more, and reduce speeds even more. But yeah, okay. One more. Okay, it's on you if we run late.
What about impact on drainage for the race safely platforms, especially in tropical areas?
Yeah. So drainage is something that needs to be worked through with really good, drainage designers, and certainly reaching out to people who have some experience in this and the like. So I think Michael's on this one, so he could no doubt tell you all about the details of drainage. And there's quite a few others getting heavily involved in shaping these up. But yeah, big consideration. Okay, let me talk to you about this intersection very quickly. Some of you have seen this one as well, because we've been promoting it quite heavily because the idea is brilliant. So this is a intersection, 100 km/h each approach, and this little doohickey here is the problem. That's a Telstra Exchange building, and it's insane, like $1 billion plus to move the damn thing. So that's blowing the idea of a roundabout at this location out of the water. If you go with a full-size roundabout, it's a B-double route. That's the arterial road. So the common thing that would happen with this is you go, we can't afford it because of all of this. So we'll just put in a right turn lane. Maybe we'll put a bit of street lighting, and and we'll reduce the likelihood of crashes. Yeah, and you will. But you're pushing to try and say, what can we do about the severity? And this region went with the idea of a compact roundabout. So they've gone smaller, and you can see the central island there is tiny. What's around that is a concrete apron. So a large vehicle turns by tracking over the concrete apron. But the straight approaches and the ability to sort of, straight line it through that was a concern, 100 km/h. So what they looked at was raised platforms again on the approach, slowing vehicles. And then they actually wanted to raise the whole intersection. Now, admittedly, with this, through the design process, there was a bit of fear, and it was dropped to an 80 km/h speed limit on the approaches to this intersection, but it's 80 km/h. Now, here's sort of your drone footage, and what you're seeing is here a fairly shallow ramp. So they come in there 80, they slow down a bit, and then this one's a little bit harsher. So those who know how at least Victoria and Queensland and a few other jurisdictions design roundabouts, we'd usually do some reverse curves on the approach to that to slow vehicles down, like a chicane into it on a rural high-speed roundabout like this. These are kind of acting like that. Slow them down a bit there in the first curve. The second curve would slow you down a bit, but these are ramp to slow vehicles down. And this is working again really well. And you can see it there. You can see the very small little roundabout there, and then the vehicles can sweep over it if they need. But there it is, still there, costs much less. The idea is that we could roll so many of these out, so many more of these sorts of things out for the cost of large roundabouts, keep those costs down. And the cost of roundabouts, full-size roundabouts, is just going berserk. I mean, I was doing a road safety audit on one up near Bendigo, and it was over $7 million for the roundabout. And it could be significantly less with a compact roundabout. We could get a lot more out there, and we know they align well with safe system principles, roundabouts in general, and these ones perform pretty well. So there'll be lots more guidance coming out on these as well, and it's something there's a lot of interest around Australia and New Zealand in. Okay, questions continue to come in. This is great. Truck tipping at these roundabouts with concrete aprons, yeah, it's a concern. And the design, it's all in the design and how you do that. There has been no truck tipping. Your design speeds and the like are important, but yeah, it's a real detailed design thing, and some guidance will come out on that. Right, there's a poll up here. True or false? Traffic signals are not safe system. True, false, or unintelligible question, which means kind of like, yeah, your question doesn't make any sense really, or I don't have enough context, or or these sorts of things. So true, false, or unintelligible question. Remember, you're not being marked on this. This is just a little bit of engagement.
Another question about any increase in rear type incidents, and I assume that's for that compact roundabout.
Yeah, again, the evaluation of it hasn't shown anything significance popped up there. There's been, you can't do a crash-based evaluation of one intersection. You have to do it under proxy measures, but they've done certainly some sort of near miss analysis in terms of videos out there for weeks and weeks on end, and haven't picked up any concerns around that.
Okay. So there's a question about left-turn slip lanes, and Ken could spend 2 hours talking about those. But what I'll do is I'll also pop in a safe system snippet we did on left-turn slip lanes. Is that okay, Ken?
Yes, you're right. You've got to hold me back here, Kathy, because
I know.
Left-hand slip lanes are quite a fascinating little topic.
Yeah, I'll pop that in the module 2 bit as well. Question about raised platform roundabout. Do you cater for cyclists through the roundabout as speeds are lower?
Yeah, well, that's debatable, because I mean the speeds are actually going to be about the same as a conventional roundabout, because you will slow vehicles through. So probably not. If you're really trying to cater for cyclists at these sort of roundabouts, you provide these separated cycle facilities, which I'll talk to you about next module.
All right, I'm going to close off the poll now and share that one.
Yeah, so this is an interesting one, and I purposely put this in at the end of this because I really give traffic signals a fair whacking around in this module, but it's all about context. And so the real answer to this is unintelligible question. So well done to those who put it in there, but I can completely understand why people put true and false. So I'm going to give everybody a thumbs up, assuming you're right. But the reason I say it's an unintelligible question is because a set of traffic signals can be highly aligned with safe system principles because they're in a low speed environment, and they're helping with the likelihood of crashes, and any severity of crashes will be minimal. They can be really badly aligned with safe system principles if they're in these high speed environments, and through speeds are going to be high, and crashes are going to be high severity. And we need to assume people are going to be running the red lights at different points. Can you just actually pop that back up again there, Kathy? I'll do it. The other so the other reason that this is a slightly unintelligible question is because of this. It's not going to draw on it. Safe system is not really a binary concept. So to say something is safe system or is not safe system is slightly unintelligible, because we know that things have better alignment with safe system principles, or not so good alignment, or lesser alignment with safe system principles. And that's why a safe system assessment is a score where you can say, well, that scored really well, or that scored really badly. And so this was one of the big gripes I had with safe system when I was, when it was first coming in, and we're getting a lot of projects saying, is that safe system? And you're like, well, it aligns well with safe system principles. It's not perfect yet. We can keep working on it. But what is full safe system alignment? I mean, what is absolute safe system? I'm not sure we have that yet for a lot of things. But we have things that are really well aligned with safe system principles in the context that they're in. So I want you to change your terminology when you're talking about safe system to say, does that align well with safe system principles? Not, is that safe system? So that was the other reason it's sort of unintelligible. potentially. Awesome. Good job, everybody. You're getting stuck into it. I'm gonna pick up the pace a little bit because I want to introduce you to your assignment that you've got as well. Okay, lane departure, mid-block locations. We know on a road like this could be any road in Australia or New Zealand, couldn't it? It's separated different streams of traffic by a white line, sometimes two white lines, but that's all. It's got a bit of sealed shoulder. It's got a road reserve there. Sometimes it's got trees, sometimes it doesn't. It's got the occasional low volume intersection. I'm sure, and you can type them in if you want. You can tell me exactly the crash types that are occurring on this 300 kilometres of road that extends just like this. So, any ideas in the crash types that are occurring, the major crash types? What's causing death or serious injury to our community? And look at this, coming in. It's like you all know what's already happening. And that's a good way to identify our systemic risk, what we call it. We know it's there. It's there. People might get a little bit fixated with these minor points, like a little kink in the road there. Okay, there's going to be a little spike in risk there, but the risk continues all throughout. And as they're coming in, run off road head on, and it's just lots of you just going run off road head on, run off road head on, and absolutely hitting trees, rolling over, hitting other vehicles. Absolutely, all of that. Yeah, maybe sometimes avoiding animals and then running off the road, hitting trees, rolling over. And then, depending on the volume of traffic on your side road intersections and the like, you can have increased run off road and you might have some other issues. We know the issues, right? And yeah, we've just got so many thousands of kilometres of this type of road out there and the like. Overtaking, intentional overtaking acts that are done inappropriately are actually a very minor part of the trauma profile of these sorts of roads. Yes, it occurs, and certainly that's there. The majority of the head-on crashes are people drifting into the oncoming lane or drifting off their lane into the shoulder or the unsealed shoulder or the roadside, waking up and overcorrecting back onto the other side of the road. So hitting these trees and power poles, here's the old the side impact pole test, 29 kilometres per hour, as I mentioned, and that's how you get your 5-star ANCAP safety rating for side impact, 29 kilometres per hour. What do we drive, 100, 110 on those sorts of roads with trees, power poles, just shooting by all the time? And we've said, Safe System says people make mistakes. They're going to leave the road. They're going to fall asleep at some point. They're going to be distracted. They're going to be on their phone, whatever it is, they're going to leave it. We need to manage the energy here. And we are so far off the vehicles doing that. And so we need to think about how we do that. I mean, here's a crash at about the 60 kilometre per hour predicted speed. And this is the kind of violence that we see in terms of energy transfer. It's just 60, predicted 60. I mean, that is, that just shows you how much energy is involved in some of these crashes with point source hazards. So our traditional approach to these, roadsides, like we'll talk about the roadsides now, is to clear all those fixed hazards, those point source hazards. Chop down the trees, remove the power poles or push them right back into the properties or underground it. And we know that reduces road trauma, the likelihood of crashes, because people leave the road and they don't crash and they come back. Okay, but this graph I think is really important to understand that we have a run-off road casualty crash rate per 100 million VKTs. I'll give away a prize to the person who can tell me what VKT stands for first. So this is your crash rate, okay? Yep. Angela was first in there, vehicle kilometres travelled, well done. prize there, Kathy. You can see there that as you clear these areas and create this clear zone, we see that they drop significantly, and then they asymptote out around the 4.5 casualty crashes per 100 million vehicle kilometers traveled. So that tells us something immediately. We've got a residual trauma, even though we're clearing and clearing and clearing. And what I want to say here is that the idea of a clear zone as such is not necessarily a safe place to be. And the reason for that, and this residual crash, are a couple of things. There is rollover. So there's vehicles that leave the road, they try to get back on, they're yawing, they're going, flying sides. It's chaotic in this time, and they roll over. And they have serious injuries, occasionally death associated with it. It's less severe than hitting that pole, but it is a significant issue. We also have just this continual distance. They're going well beyond any set clear zone as such, and hitting trees, power poles, and everything that are just outside these clear zones. So, it continues to extend and extend and extend, but they're going further and further. So what we know about clear zones as such, so areas from the edge line out that are cleared of fixed hazards, is that the most value is in these early few meters. But we do know that a barrier system, a flexible barrier system, outperforms a clear zone for passenger vehicles, which are the overwhelming majority of run-off-road crashes on these big sort of long straight roads where people fall asleep and they get distracted and they leave the road. A flexible barrier system is our most aligned safe system option. It's more aligned than clearing the roadside for 15 meters. It's a bit, weird. And I would not have ever said that 10 years ago, or maybe 10 to 15 years ago, I definitely wouldn't have said that, because barrier technology was not good enough. Hitting that barrier held enough of its own risk that you would, that we would prefer vehicles to be in the open paddock and maybe rolling over, but too much hazard with hitting the barrier as well. But the barrier technology has gone off the charts. It is amazing. And so it is friendlier to hit a barrier than it is to take your chances in the open environment. Now, this is going to be controversial because, well, for many reasons. But anyway, Austroads has finally caught up. So I used to, in running this, I've been running this course for a long time now, about 7 years or something. And I used to pop this up and say, this is exactly how Austroads would guide you to design a new road in general. Sealed shoulder, well, probably not your truck rumble strips. That's not a thing in the Austroads guides, but certainly, shoulder, 3.5 meter lanes, big wide median, other carriageway, and all your hazards just at clear zone. This is the Hume. And you sort of design it to that, and there's a huge amount of death and serious injury up the Hume, or there was back at this time when I took the photo. And that's because this is not our best way of reducing risk. And so have a look at the new Austroads Guide to Road Design Part 6, Roadside Design, Safety and Barriers. It's really stepped us up into a new level. But really what we know is that the best alignment with safe system principles, and this is sort of high alignment to low alignment with safe system principles for these mid-block high-speed roads, is we know that full containment with barrier systems is best. Right? Yeah, you want about 4 to 6 meters in your shoulder is nice. I mean, there's a strategic cost challenge you've got to work through there, because the wider you make your shoulder to offset the barrier, the less probably length you'll be able to get out of it. Ideal would be that if you can fit it, because you can fit a broken down car over there nicely, and it's not far enough, because if you went way out here with your barrier, you've got enough space to create that potential rollover. You get worse angles of crash onto the barrier, and we know barriers, up to about 25-degree crash is probably about best. But It's full containment. It's the bumper bowling of roads. Yeah, they're going to fall asleep. They're going to be distracted. They're going to, whatever it is, they're going to leave their lane, and we're going to hold them in the safe area. And then it sort of, you know, drops down with alignment with safe system principles. Wide center lines, pretty good, but they're only addressing the likelihood of the crash. We've got nothing in the middle there for the severity of crash. And there's a bit of jumping around here with, depending on your volume, exactly which is best. But we won't go into too much of that detail. And there's lots of different cross sections out there, but you can see the difference between this cross section where you've got these big wide areas and you've got, you know, no barrier systems, but some clear zone out here, compared to barrier system, barrier system, barrier system. And you can see here, it's a very small text, but that says 4-star road, and that says 5-star road. And that's sort of your IRAP star rating of roads. But look at the land take, the envelope, the amount of space we're taking for this. You know, all of that compared to this, and we get a better safety outcome. The safe system is not always going to cost you more. And we've got some great examples of projects where these were the cross sections they were originally talking about, and they were going to have to acquire farmers' land, and they were going to have to, you know, chop down heaps of native vegetation. And, you know, the safe system assessments come through and say, actually, you're going to get a better safe system outcome, more aligned with safe system if you do something like this. And plus, it's going to save, you know, $50 million. Now, admittedly, safe system aligned features can often cost more. So, but, you know, but there are examples of that. And we talked before about clearing trees and alike. I mean, that's pretty much, you know, off the cards for many reasons these days. And that's probably, you know, the road reserves are the place of a lot of our native vegetation that's left, and we should be really looking to protect that. And hang on a second, we've got win-win here. We've got a better environmental outcome, we've got a better road safety outcome, and it probably costs less. So these are all pretty amazing things. I'm not going to go through lots of cross sections. Yeah, you've got to think about the detail. I mean, you've got to think about how vehicles will break down and where they'll be, and we get, you know, lots of pushback. We have had lots of pushback on these sorts of things, so that community interaction and context is really important. And lots of guidance available on this sort of stuff. I mean, we do 3 days worth of barrier design discussion about all these little detailed intricacies. But, you know, the big theme takeaway from this is those continuous barriers are amazing in terms of reducing death and serious injury to our community. Bit of work on the detail of how to design them.
Ken?
Yeah, I was thinking, do I do this or do I ask for questions? Okay, I'll ask for questions.
Sorry, it's a very active group, which is really good. But tell us about motorcyclists.
Yeah, okay, really good question, because there's a lot of chatter amongst people about motorcyclists and barriers, and I am going to defer this one to our next module, because I specifically talk about motorcyclists and barriers and a lot of the myths that are out there, and a lot of the you know, the elements of the discussion that are genuine and ways that we can treat that. So I'll just defer that. Sorry.
No, that's absolutely fine. Thank you. Do you have an example of a measure that falls under exposure likelihood and severity?
Exposure, likelihood, and severity. No, probably not all three. Definitely, I could, you know, likelihood and severity. There's quite a few of those. Even just a regulatory speed limit reduction is going to be likelihood and severity. But no, not all three. If I think of one, I'll let you know.
Thank you. And where would a scenario fit where there is no shoulders but roadside barriers, as in the case in a lot of rural roads these days?
Yeah, good question. So really, when you safe system assess something like that, what you're doing is you're saying the likelihood of crashes may be up a little bit, because if somebody leaves their lane and they're into an unsealed shoulder or into the, you know, the dirt or the like, the likelihood of them crashing is still up, but the severity comes down a heap as a result of the fact that there's the barrier system there. So this is where we talked about risk being the product there of exposure times likelihood times severity. So what you're actually working out there is how many vehicles are traveling on that road, exposure. What's the likelihood of them leaving the road? So you can factor a whole lot of things into that. And one of them is that unsealed shoulder or the like, because that's going to bring up your likelihood of crashes up. And then what's the severity going to be? And that's going to be way down. And so what you'll end up with is a certain score that's factored all of that into account. You would get a lower score if that was a sealed shoulder as well, because the likelihood would be down a bit. And this is where a safe system assessment can be quite useful to see how that all plays out. Communicating this with the public's often a challenge, and we need to be a bit more refined, I think, in how we do that, because in the end, sometimes we're okay with more crashes happening as long as they're all much less severe. Public not so happy with that sometimes in the way that they see the road environment and the operation and their tasks that they're doing in that. Okay, anything else?
Yeah, just one follow-up one on that. Do the barriers either side not increase the risk of them being flung back into active high-speed traffic?
The barrier test requirements, so both NCHRP 350, the old barrier test requirement, and the new one, MASH, Manual for Assessing Safety Hardware, have a crash test envelope of exiting vehicles. So basically, barriers have to be designed and manufactured and so that a vehicle that hits it does not get flung back out like that. And in fact, it has to be contained within a fairly narrow envelope. That being said, occasionally, so that's test conditions, the real world, all sorts of craziness can and does happen. What you've got is a vehicle that comes back into the carriageway. And if this is so this is a carriageway of all vehicles in one direction. What we're seeing is, if anything, rear end crashes very, you can do them at very high, or quite high speeds when you've got both vehicles traveling and everybody's okay, or sideswipe style crashes. Yes, if it was to be a vehicle flung back onto the other carriageway and then a head on, we've got a particular concern. So that's something to be thinking about. But don't forget, though, that every one of those barriers is designed and tested to keep the vehicle fairly much within an envelope, rather than that sort of I don't know, like WWF wrestling, bouncing a car back onto, out there onto the other side of the road.
Okay, I think maybe Joel's found something that reduces exposure, likelihood, and severity.
Yeah.
If it's a section of road limited to only buses or public transport. What do you think?
So it's good if you think about it from a holistic context, and I'm going to say yes. But when we actually get into the mechanics of doing a safe system assessment, we break things down by crash types, and so that probably would, yes, give us exposure, likelihood, and severity, but it will be in different sections. Anyway, it'll become a little bit clearer when we start getting into the actual assessment methodology. But that's good. Give him a prize.
Okay, all right. We've got 9 minutes. Sorry, I keep stopping you with questions, but yeah, wrap it up, Ken.
I just want to say that we need to continue to innovate in thinking about energy of crashes. This is just one random example, a device I like, a crash, forensically analysed in big detail of a vehicle that struck a power pole at 93 kilometres per hour. So yeah, it wasn't a roundabout, so that didn't slow that vehicle down as much as we like. Maybe they would have been going faster through an intersection, but they hit the power pole, and in an old Ford, 4 young males, all survived, all without serious injuries. And that is incredible, considering that the reason is that the pole had a Raptor cushion, and that's an energy absorbing cushion around the power pole. It also acts in this really neat way, which is to deflect energy. It rotates when struck. Like they say in martial arts, where, you know, deflect the energy of the punch. I've never done martial arts in my life, but I watched The Karate Kid. So the idea is that it hits it, it rotates, your vehicle isn't stopped immediately, it moves it along and washes off energy. And just an example of where we need to continue to innovate and try and think about these things. And jump through the quiz there, Kathy, because I need you to tell people how to do their assignment.
Yep, for sure. Okay, so I will share my screen.
So you're going to have a quiz at the end of this, just like the other one you did. You do that normal quiz. You also have this very short assignment to do. And the assignment is really about you getting really clear in your mind what influences exposure, what influences likelihood, and what influences severity. And so you see there, Kathy's got in Module 2, Safe System, Module 2 assignment.
Just popped in there the snippet on left turn lanes and also the Austroads webinar. So you jump into your assignment and there's a Word document there for you, which should open up.
So you're going to open that Word document and you're going to be filling out the anything that is highlighted yellow. That's your job, okay? Is it same on the USB? Yes. So you're going to put your name in. What you're going to do is pick an intersection, okay? It could be any intersection you want. It could be the one out the front of your house or your office. It could be one you thought about, oh, when I was on holiday, that was an interesting intersection. Does not matter. You pick it, okay? And you're going to put a link to the street view or the location by Google or something so we can have a quick look at it as well. The instructions are all up here, step by step, so you just follow those. So your name, you pop that intersection in there. Now, you're not going to go to the intersection. You can if it's out the front of your house, obviously, but you can just go via Street View or have a look at it. So scroll down a bit, Kathy. What we want you to do is fill out this matrix, this little sort of simplified matrix table. And you're going to look at that intersection, you're going to say, what characteristics of that intersection are influencing the exposure to crashes, okay? And that could be things like it's high volume of vehicles. It's got a lot of legs to the intersection. It's got a lot of pedestrians crossing, whatever it is, exposure to crashes. It's really about what's influencing the number of people going through there on any transport mode. Then the next one over to the right, you're going to go to what factors in that intersection are influencing the likelihood of crashes. And these are all those things like, okay, is it signalized or not? Does it have really good line marking? Is there a see-through effect? Is it confusing? Does it have good warning signs? What's the surface like? These are all things that influence the chance that somebody will crash at that intersection. And then you're going to look at the severity. What are some of the factors that influence the severity of the crashes when they occur? And of course, they're likely to be things like, what are the speeds vehicles are going through? Are there, lots of heavy vehicles maybe, and this is going to be more severe, the angles of crashes, and these sorts of things. So you're going to go, that's what's currently there, and you're going to assess it in the green shaded row there. In the white one underneath it, we just want, how many? One thing that you could alter in that intersection that would specifically influence that column. So change the exposure. How would you change the number of people going through that intersection exposed to the crashes? The next one, how would you influence the likelihood of people crashing? And the next one, how will you influence the severity of people crashing? And so the first one, the green shaded row, we're going to look for between 1 and 3. So you can just stick it to just one thing on all of these. You could go up to 3 if there's lots of things you want. And then we will have a look and mark this, and it'll predominantly be marked on your ability to correctly categorize things that you point out. Yeah, we'll have a look at your intersection and say, make some, calls as to whether we think that done, is a factor in there. But predominantly, this is a categorization assignment. Getting very clear in those categories. Any questions on the assignment?
So you then PDF it and submit.
Yep, just in through Moodle there. You submit, and look, gee, we're 4 days and 4 hours to do it.
And I've conveniently made it, you can't submit it before 1 p.m. today, but let me jump in and change that. Sorry about that. So instead of this, it should say there's a submit function there.
Yep. So with this exercise, I really think it shouldn't take you more than about 15 minutes, maybe half an hour if you're really getting excited by analyzing your intersection. But if you are confused by this, if you find yourself spending a lot of time on it, stop, get in contact with me or Kathy, and we will walk you through it and help you through it. It should be a very quick exercise. You can do it all from your desk. You can do it and just pop in, populate that table, fill out your name, PDF it, and get it in. Think about that categorization. Look back at the notes if you want. Look at the Safe System Assessment Framework because it helps you with categorization as well. And categorization is a really important part of a safe system assessment. Any other questions? At 1 minute to the end.
No, it doesn't need to be the same as the later assignment. So some of you have probably already jumped into module 5, which is where we have assigned you a site. This is actually one that you choose yourself. So you choose wherever you want. Is it the same one that's in the USB? Yes, it is. So the assignment sheet is on your USB and in Moodle. And I should have made it being able to submit it now.
So, yeah, pick an intersection. I'd say just do the one nearest to your house or one you go through every day and really well, and break it down into those categories. Really think about it through all those categories. Excellent. Okay, so Kathy, when's our next module?
Tomorrow.
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 And we'll address some of those motorcycle cyclist questions that came up. Thank you very much, everybody. Really wonderful participation, interaction, great group. I love it, and enjoy the rest of your day.
Thanks, Ken. Thanks, everyone.